Hello students, welcome to another lecture on software design and architecture. In this lecture we are going to talk about UML activity diagrams and we are going to see how we can model using those diagrams. So a UML activity diagram shows sequential and parallel activities in process. So whenever we are going to map or model the activities happening, either they are sequential or parallel, we can take this help from the activity diagrams. They are useful for modeling the business processes, workflows, data flows, or any complex algorithms. So by now we have modeled our classes, but we have not mentioned that if there is a complex algorithm or a flow, how we will understand that. Activity diagram is one of the dynamic models, and that's why it covers one of the dynamic aspects of the system. And essentially activity diagram can be considered as a flowchart as it shows the flow of control from one activity to another activity, but in the notation it is very much different from the flowcharts. So you can consider the activity diagram as a object-oriented form of flowchart in the UML. We will be looking at the basic activity diagram notation, which includes action, partitions or swim lanes, fork, a join, or an object node. So once again, this diagram is used to show a sequence of actions, and those sequence of actions can also be parallel. There are two important points that you must know. Once an action is finished, there is an automatic outgoing transition, and the diagram can show both the control flow and the flow of your data. This is one of the examples of activity diagrams where you can see there are the swim lanes. So this left hand side and this right hand side and this partition in the middle are three different swim lanes, and you can see that we are naming these three different partitions or swim lanes differently. So this one on the left hand side is named as fulfillment, the middle one is the customer service, and then on the right hand side we have the finance. This circle here represents the start of the diagram. So in our case, this receive video is an action, and as soon as this action completes, it will automatically transit towards the next action. This solid line here represents a fork, which means there is one incoming transition, and as a result there are multiple outgoing transitions. Now as a result of continuation, the activities might span and go towards the different lanes. So for example, here in this case, after the fork, we are creating the activity called fill order, and this fill order activity is resulting into an object node. So an object node is produced or used by actions. This allows us to model data flows or object flows, which means the result of this activity fill order will be an order. So you can consider this order as an object or a data. This object here is further used by the deliver order activity, and deliver order activity further goes towards this solid line, and this solid line here is contrast to the fork. So we call this as a join. So the difference between a fork and join is that join is having multiple incoming transitions or objects and one outgoing transition. And this fork also means that this outgoing transition will not happen until and unless all the input flows arrive at this join. And in our case, once this join completes, we will proceed for the close order activity. And once this activity completes, we represent the end of activity with this hollow circle. So in this previous activity diagram, whenever an action or an activity completes, flow of control will pass immediately to the next action or activity. A flow of control has to start and end at some place. So initial state, a solid ball, will represent that we are starting the activity diagram from there. And the stop state will be represented with a solid ball inside a circle. Each partition, or we can call it as a swim lane, is divided from its neighbor partition and swim lane by a vertical solid line. And each swim lane has a name which is unique within the diagram, whereas each swim lane can represent some real-world entity. Each swim lane may be implemented by one or more classes. And every activity belongs to exactly one swim lane, but transitions may cross the lanes. So if you result into an activity which is finishing in one swim lane, it might start another activity into another swim lane. Such activity diagrams and its notations can be used to model any parallel activities, but in specific, it can be used to visualize the business workflows, processes, or the flow of use case scenarios. And additionally, if you want to replace it with the traditional data flow diagrams, you can use this for modeling the data. So on the screen you can see that this is a typical data flow diagram for automated course registration system. We can replace this diagram and use the same flow and represent it with the help of the activity diagram. So that DFD shows that a student will start and complete the application, which will result into an object called application object. On the other swim lane, which is the registration swim lane, the check course availability activity will start. And based on some conditions, it will finally result into the checking of application qualification. And if the qualification is acceptable, the activity will stop. If your activity and the sequence of processes cannot be covered into a single diagram, you can take help of multiple diagrams, and to combine multiple diagrams you can use the rake symbol. The rake symbol indicates this activity is expanded in a sub-activity diagram. So for example, after filling the order, you want to represent the other sequences in second activity diagram, you will simply use the rake symbol and write the name of the sub-activity diagram. And then you can expand that into another diagram. There could also be scenarios when we need to show the conditional branches. So for that we can use the decision symbol. And when the branches are created, after the decisions are finalized, we can merge them back and converge them to the closing point. You must make sure that there is an important difference between merge and the join. When we use the join symbol, it is important for the join for all the flows to reach at that point, and then it continues to the next activity. Whereas in case of merge symbol, which is there in the case of decisions and branches, any input that will arrive first will lead to the continuation of the flow. In a scenario where time can cause or generate an event, we can use the signals notation. So for example, in this activity diagram where we are sending the invoice after receiving the video order, we can keep on resending the invoice based on some specific time duration. To represent that, we can use the signal notation. So this signal notation here represents that after each 30 days of period, we are going to resend the invoice automatically. And similarly, if there is a request for cancelling the order, we will simply initiate the cancel order activity and finally stop. While activity diagrams are very powerful and have a rich notation, it is important that we use them for very complex processes. If we have some simple processes, we can use simple use case texts, write the scenarios, and they would be enough. And for the very large and huge processes, we should take advantage of the rake symbol, and instead of putting everything into a single activity diagram, we should go for the sub-activity diagrams. This will help us reduce the complexity and understand the diagrams easily. On the first overview, level 0 diagram can be created, and then keeping on reviewing and reducing the complexity, we can expand the details in the sub-diagrams. At level 1 and level 2 and so on. As we are discussing the next generation point of sale system, let's try and create an activity diagram for the process sale use case. However, you should keep this in mind that we are just seeing this diagram for understanding purposes. Otherwise, we know the fact that whenever the use case is simple and the process is very trivial, we do not need to create the activity diagram. So in this diagram, we have created 4 swim lanes, including customer, cashier, next generation point of sale system, and authorization service. We are starting from the shop and fill cart activity, which results into the creation of cart object. This cart object is used by the enter cart items activity, and enter cart item activity is completed, which results into calculation of taxes and discounts. And then based on a condition between cash payment or the card payment, we move for the further activities. And if the payment is based on the card, we jump on to the authorization service swim lane, which authorizes the payment and returns back to the merge. And if the payment was cash, we simply jump on to the merge part and create the receipt. And once the receipt is created, we go back to the cashier swim lane, which hand over the items. And in the customer swim lane, we generate the receipt object. And then for further understanding, you can have a look at the example activity diagram for modeling the process of ATM transaction. Similarly, there is another activity diagram which models the process of mortgage requests. And this activity diagram represents the process of enrolling in the university for the first time. So you can think of many other examples, and there could be scenarios given to you with the help of which you will be required to create those activity diagrams. And for further understanding, you can read the chapter number 28 from Applying UML and Patterns. Good luck!